Number system. We know the importance and place of numbers in mathematics. Now, let us observe the following sentences. My age is 11 years. Height of Vishnu is 142 centimeters. There are 12 teachers in our school. My father bought a computer to me for rupees 16,000. I wake up at 5:30 a.m. every day. We use this type of sentences having numbers regularly in our daily life. Isn't it? Numbers are part of our human life. Hindu-Arabic number system is used in our daily life, and we know that there are 10 digits in it. They are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Each one is shown as one digit. Activity. Observe the place value table and write the numbers in words and in expanded form. Let us write the given number in expanded form. The given number is 76,289. Now let us write it as 7 into 10,000 plus 6 into 1,000 plus 2 into 100 plus 8 into 10 plus 9 into 1. Now observe. 1. 10 is equal to 10 ones. 100 is equal to 10 tens is equal to 100 ones. 1000 is equal to 10 hundreds is equal to 100 tens is equal to 1000 ones. 1 lakh is equal to 100 thousands is equal to 1000 hundreds is equal to 1 lakh ones. 1 crore is equal to 100 lakhs is equal to 10,000 thousands is equal to 1 crore ones. Place value in a number. Observe the number 6 crore 32 lakh 78,954. In this number, place value of 4 into 1 is equal to 4. Place value of 5 into 10 is equal to 50. Place value of 9 into 100 is equal to 900. Place value of 8 into 1000 is equal to 8000. Place value of 7 into 10,000 is equal to 70,000. Place value of 2 into 1 lakh is equal to 2 lakhs. Place value of 3 into 10 lakhs is equal to 30 lakhs. Place value of 6 into 1 crore is equal to 6 crores. Find the difference in the place values of 7 in 1,70,071. Solution. The place values of 7 which is in the right, that is, the place value of 7 in tens place is equal to 70. In the same way, the place value of the second 7 is equal to 70,000. The difference between these place values is equal to 70,000 minus 70 is equal to 69,930. International system or English system. Reading and writing a 6-digit number is denoted by lakh in our country, but in other countries the same number is read and written in different ways. For example, 2, 3, 4, 1, 3, 7 is read as 2,34,137. In international system, the same number is read as 234,137. Prime and composite numbers. We have learnt about factors in lower cases. If a given number is divided by a natural number without leaving any remainder, then that neutral number is called a factor. This is also called divisor. For example, 1, 2 and 4 divide 4 without leaving any remainder. So 1, 2 and 4 are factors of the given number 4. 1 is having only one factor itself. 2, 3, 5, 7 and 11 have 4 factors only. They are 1 and the number itself. These are called prime numbers. Let us take a natural number n such that n is not equal to 1. A number which has two factors, 1 and the number is called as a prime number. If n not equal to 1 and also n is not a prime number, then the number is called composite number. Multiples and factors. Observe the table for 2. 2 into 1 is equal to 2. 2 into 2 is equal to 4. 2 into 3 is equal to 6. 2 into 4 is equal to 8. 2 into 5 is equal to 10. 2 into 6 is equal to 12. 2 into 7 is equal to 14. 2 into 8 is equal to 16. 2 into 9 is equal to 18. 2 into 10 is equal to 20. 2 into 11 is equal to 22. The numbers 2, 4, 6, 8, 10 are formed by multiplying 2 with natural numbers. These numbers are multiples of 2. We know that 2 into 3 is equal to 6. 2 is said to be a factor of 6. 6 is said to be a multiple of 2. Every number is a multiple of itself. Every number is a multiple of 1. There are infinite numbers of multiples for a natural number. To find the multiples of a natural number, we have to write the product of that number with all the natural numbers. Factors. If 2 or more numbers are multiplied to get a product, then these numbers are the factors of that product. Let us write the factors of 32. 1, 2, 4, 8, 16, 32 are the factors of 32. 32 is the largest factor and 1 is the smallest factor. Common multiples and factors. A. The factors of 15 are 1, 3, 5 and 15. The factors of 20 are 1, 2, 4, 5, 10 and 20. Common factors of 15 and 20 are 1 and 5. To find the common multiples of 10 and 15, the multiples of 10 are 10, 20, 30, 40, 50, 60, so on. The multiples of 15 are 15, 30, 45, 60, so on. The common multiples of 10 and 15 are 30, 60, so on. Greatest common divisor, GCD. Observe the factors of 16 and 18. Factors of 16 are 1, 2, 4, 8, 16. Factors of 18 are 1, 2, 3, 6, 9, 18. The common factors of 16 and 18 are 1 and 2. Out of these, the greatest common divisor is 2. Find the GCD for 15, 25 and 30. Solution. Write the factors of 15, 25 and 30. The factors of 15 are 1, 3, 5 and 15. The factors of 25 are 1, 5, 25. The factors of 30 are 1, 2, 3, 5, 6, 10, 15 and 30. Common factors of 15, 25 and 30 are 1 and 5. In these, 5 is the greatest, hence 5 is the GCD of 15, 25 and 30. Prime factorization method. Write the given number as the product of prime factor. 48 is equal to 2 into 2 into 2 into 2 into 3. 60 is equal to 2 into 2 into 3 into 5. The common factors of 48 and 60 are 2 into 2 into 3. Their product 12 is the GCD of 48 and 60. Division method. First, divide the larger number by the smaller number. Divide the quotients with their remainders. Continue the division till we get 0 as remainder. The largest quotient with 0 as remainder is GCD. Find the GCD of 540 and 696 by division method. Let us divide 696 by 540. We get the remainder 156. Again divide 540 with 156. We get 72 as remainder. And again divide 156 with 72. We get 12. So GCD of 540 and 696 is 12. Least common multiple LCM. Among the common multiples of 2 or more natural numbers, the smallest is the least common multiple LCM. Write the multiples of 4 and 6 and then observe. The multiples of 4 in order are 4, 8, 12, 16, 20, 24, 28, 32, 36. The multiples of 6 in order are 6, 12, 18, 24, 30, 36. Now, common multiples of 4 and 6 in order are 12, 24, 36. The least common multiple of the above is 12. 12 is the least common multiple of 4 and 6. Finding LCM by division method. How to find LCM of 12, 15 and 20? Step 1. Divide the given numbers with the smallest prime number which divides at least 2 numbers. Bring down the number as it is which is not divisible. Let us write 12, 15, 20. Divide with prime number 2. Write 6, 15, 10. Step 2. Continue dividing with the smallest prime number till the least common factor is 1. 12, 15, 20. With 2, we get 6, 15, 10. Again, with 2, we get 3, 15, 5. Now, with 3, we get 1, 5, 5. Now, divide with 5. We get 1, 1, 1. Multiply all the factors. 2 into 2 into 3 into 5 is equal to 60. LCM of 12, 15 and 20 is equal to 60. Relation between GCD and LCM. Find LCM and GCD of 30 and 48. Let us divide 48 with 30. We get the remainder 18. Let us divide the quotient 30 again with 18. Now we get the remainder 12. Divide the quotient 18 again with 12. We get the remainder 6. Now divide the quotient 12 with 6. We get the remainder 0. So GCD of 30 and 48 is 6. To find the LCM, write 30 and 48 and divide with 2. We get 15 and 24. Now divide it by 3. We get 5, 8. So the LCM 2 into 3 into 5 into 8 is equal to 240. The product of GCD and LCM is equal to 6 into 240 is equal to 1440. The product of the given two numbers is equal to 30 into 48 is equal to 1440. We conclude that the product of the numbers is equal to the product of LCM and GCD. The product of two numbers is equal to the product of their LCM and GCD. If A and B are two numbers and their LCM and GCD are L and G respectively, then A into B is equal to L into G. BODMAS rule. Examples: 4 into 5 plus 35 divided by 7 minus 3 is equal to 4 into 5 plus 5 minus 3 is equal to 20 plus 5 minus 3 is equal to 25 minus 3 is equal to 22. Simplify 240 minus 40 minus 3 into 12 minus 9. Solution: 240 minus 40 minus 3 into 12 minus 9 is equal to 240 minus 40 minus 3 into 3 is equal to 240 minus 40 minus 9 is equal to 240 minus 31 is equal to 209. If there is no sign, either plus, minus, into, divided by between a number and a bracket, it means multiplication. If there is plus sign before a bracket, then the terms can be written directly after removing the bracket. If there is minus sign before a bracket, change the sign of the terms within the brackets if that form plus sign to minus, minus sign to plus sign. Rules of divisibility. Fundamentals. In the process of division, we say that a number divides another number only when we get the remainder as 0. A natural number is divisible by 2 if and only if the digit in its units place is either 2, 4, 6, 8 or 0. A natural number is divisible by 3 if and only if the number obtained by adding its digits is divisible by 3. A natural number is divisible by 5 if and only if its last digit is either 5 or 0. A natural number is divisible by 10 if and only if its last digit is 0. Divisibility rule for 4. A number is divisible by 4 if and only if the number formed by the two digits in the tens and unit place of the given number is divisible by 4. Example: the number formed by the digits in tens and units place of 5082 is 82. This number is not divisible by 4. Hence, 5082 is not divisible by 4. If the number formed by the last two digits of the given number is divisible by 4, then the number is divisible by 4. Divisibility rule for 8. If the number formed by the last three digits of a given number is divisible by 8, then the given number is divisible by 8. A natural number is divisible by 9 if and only if the sum of digits is divisible by 9. Whole numbers 1, 2, 3 are called as natural numbers. All the natural numbers and 0 are put together are called as whole numbers. These are also known as a set of whole numbers. This is denoted by W. W is equal to 0, 1, 2, 3, etc. When all the natural numbers and 0 are put together, then they are called whole numbers. Properties of 0 and 1 in whole numbers. From the above examples, we know that if 0 is added to any whole number, we get the same whole number. Let A be another whole number, then we know that A plus 0 is equal to 0 plus A. For every whole number A plus 0 is equal to 0 plus A is equal to A. This property is called additive identity property and 0 is called additive identity. When 0 is divided by any non-zero whole number, then the quotient is 0. Division with 0 is not defined if that A divided by 0 is undefined. A is any number. If A is any whole number, then A into 1 is equal to 1 into A is equal to A. 1 is called multiplicative identity. To present whole numbers on a number line, draw a straight line and mark a point on it. Mark another point towards the right of 0 as 1. The distance between 0 and 1 is 1 unit. Mark another point towards the right of 1 at a distance of 1 unit as 2. Continue the same process and mark 3, 4, 5. What is the distance between 3 and 5 on this number line? We know that it is 2 units. On number line, 5 is towards right of 3. So, 5 is greater than 3 or 3 is less than 5. From these examples, we say that on the number line, if a number is towards the right of another number, then the number is greater. The number towards the left of any other number is smaller. Example 4 less than 9. Addition on number line. Addition of whole numbers can be shown on number line. Let us see how to add 4 and 5 on the number line. To add 5 and 4, start with 4 and identify a whole number at a distance of 5 units. From 4, distance of 1 unit is 5. From 5 to 6, 6 to 7, 7 to 8, 8 to 9. Thus, 4 plus 5 is equal to 9. Integers. When all the positive numbers 1, 2, 3, negative numbers -1, -3, -2, -1 and 0 put together, they are called integers. Set of integers is denoted by the letter Z. Z is equal to -3, -2, -1, 0, 1, 2, 3. Representing integers on the number line. -1, -2, -3 are called the additive inverses of 1, 2, 3, etc. respectively. In the same way, 1, 2, 3 are additive inverse of -1, -2 and -3 respectively. Observe the following. 4 minus 4 is equal to +4 minus 4 is equal to 0. 12 minus 12 is equal to +12 into -12 is equal to 0. 0 is lesser than all positive integers and greater than all negative integers. 0 is neither positive nor negative. The smallest positive integer is 1 and the greatest integer is 1. Addition of integers. Activity. Take 2 dice and write numbers from 1 to 60 on one dice and 3 plus symbols and 3 plus symbols on 3 minus symbols on another dice. The players have to place buttons or colored beads at 0 and start the game. Both the dice have to be thrown simultaneously to place the bead on the number line. Example, let us see the addition of 3 and 5 on the number line. Starting from 0, moves 3 units to right. From there again, moves 5 units to right. Reach 5. 3 plus 5 is equal to 8. And -3 and -5 on the same number line. Example, let us see the addition of 3 and 5 on the number line. Starting from 0, move 3 units to right. From there, again move 5 units to right. You will reach 8. If therefore, 3 plus 5 is equal to 8. Example, add -3 and -5 on the number line. Starting from 0, move 3 units to left and again move 5 units to its left. -8. For -3 plus equal to +8. While adding negative integers, move to left, left shift. While adding positive integers, move to right, right positive. Subtraction of integers. We know that subtraction is inverse to addition. If that 8 minus 3 is equal to 5, implies 8 is equal to 5 plus 3. Subtracting 4 from 9 is adding a number to 5 so that their sum is 9. Which number to be added to 4 to get 9? We know that 5 is to be added to 4 to get 9. 9 minus 4 is equal to 9 plus minus 4 is equal to 5. To subtract 4 from 9 and add the additive inverse of 4, if that is minus 4. Let us observe the following example. Subtract minus 4 from 10. Solution. Subtracting minus 4 from 10 is finding the number to be added to minus 4 to get their sum 10. Observe this on the number line. Minus 4 is at a distance of 14 units from 10. If that is on the number line, if 14 is added to minus 4, then it becomes 10. Therefore, 10 minus minus 4 is equal to 14. If that, to subtract minus 4 from 10, add 4, the additive inverse of minus 4 to 10. 10 minus minus 4 is equal to 10 plus 4 is equal to 14. To subtract an integer, add its additive inverse. Multiplication of integers. To find the product of two numbers with different signs, first find the product, then place inverted comma sign before their product. Example, 3 into minus 8 equal to minus 24. 8 into minus 3 is equal to minus 24. Minus 5 into 4 is equal to minus 20. 6 into minus 5 is equal to minus 30. The product of a negative integer and positive integer is always a negative integer. Division of integers. As in whole numbers, multiplication and division of integers are inverse operations in integers also. We know that 16 divided by 8 is equal to 2, which means 2 into 8 is equal to 16. 64 divided by 4 is equal to how much? Means what number should be multiplied by 4 to give the product of 64? 75 divided by minus 15 means what number should be multiplied by minus 15 to give the product 75? That is minus 15 into how much is equal to 75? We can easily say that the required number is minus 5. Hence, minus 15 into minus 5 is equal to 75. Therefore, 75 divided by minus 15 is equal to minus 5. Common fractions and rational numbers. While representing rational numbers, 1. Denominator is taken as positive value, and 2. Numerator and denominator are written in lowest terms. Comparison of rational numbers. Rational numbers can be compared in two ways. 1. Using number line. 2. Using the arithmetic method. Rational numbers can be compared easily using number line. Rational numbers can be arranged on number line in an ascending order from left to right. In fractions having some denominator, the fraction with bigger numerator is the bigger number among the fractions. Example, compare the fractions 3 by 8 and 5 by 12. Solution, find LCM of 8 and 12. 8, 12 divided by 4, we get 2, 3. LCM is equal to 4 into 2 into 3 is equal to 24. Now let us convert the given fractions into equivalent fractions such that their denominator is 24. 3 by 8 into 3 by 3 is equal to 9 by 24. 5 by 12 into 2 by 2 is equal to 10 by 24. The fractions we got are 9 by 24 and 10 by 24. In these fractions, 10 by 24 is bigger. Numerator is bigger. Therefore, 3 by 8 is less than 5 by 12. Arranging fractions in an ascending order. For fractions whose numerator is equal. Example, arrange these fractions in ascending order. Solutions. In fractions having same numerator, we know that the fraction having bigger number in the denominator is the smaller fraction. Therefore, 7 by 17 less than 7 by 15 less than 7 by 11 less than 7 by 10 less than 7 by 9. Arranging in ascending order 7 by 17, 7 by 15, 7 by 11, 7 by 10, 7 by 9. Multiplication and division of rational numbers. We know that multiplication of natural numbers is repeated addition. This means repetition of addition again and again. For example, to find 1 by 4 into 8, we have to write 1 by 4 8 times and then add. Therefore, 1 by 4 into 8 is equal to 1 by 4 plus 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 1 by 4 is equal to 8 by 4 is equal to 2. Simplify 1 by 3 into 9. Let us write 1 by 3 9 times. Now it becomes 9 by 3 is equal to 3. 5 by 4 into 2 is equal to 5 by 4 plus 5 by 4 gives rise to 10 by 4 is equal to 5 by 2. Let us observe the above results once again. 1 by 4 into 8 is equal to 1 by 4 into 8 by 1. That is 1 into 8, 4 into 1 means 8 by 4 is equal to 2. 1 by 3 into 9 is equal to 1 by 3 into 9 by 1 is equal to 1 into 9 by 3 into 1 is equal to 9 by 3 is equal to 3. 5 by 4 into 2 is equal to 5 by 4 into 2 by 1 is equal to 5 into 2 by 4 into 1 is equal to 10 by 4 is equal to 5 by 2. Similarly, 1 by 3 into 1 by 2 is equal to 1 by 6. 4 by 5 into 2 by 3 is equal to 8 by 15 and 6 by 8 into 3 by 2 is equal to 18 by 16 is equal to 9 by 8. If a by b and c by d are two rational numbers, then their product is defined as a into c by b into d. The product of two rational numbers is also a rational number. If a by b is a rational number, then 1 into a by b is equal to a by b into 1 is equal to a by b. If a by b is a rational number, then a by b into 0 is equal to 0 into a by b is equal to 0. Each and every non-zero rational number has a multiplicative inverse. 0 does not have a multiplicative inverse. Decimal fractions. In a decimal fraction, there will be a whole number part and a decimal part. Decimal place divides the number into two parts. Whole number 54.352. 54 is the whole number part and the dot is decimal place and 352 is the decimal part. If there is no number in the whole number part, it should be written as 0. For example, 0.7 can be written as 0.7. To represent rational number as terminating or non-terminating decimals, we know how to write 4 into 7 by 8 in decimal form. 4 7 by 8 is equal to 39 by 8. 39 will be divided by 8. We get 4.875. Therefore, 4 7 by 8 is equal to 4.875. Similarly, writing 42 by 5 in decimal form, 42 is divided by 5, we get 8.4. According to the above decimal forms, the places coming after decimal point are finite. This type of decimal form is called terminating decimal form with a terminal place. These are called terminating decimals or decimals with an end. The digit or digits which are repeated again and again without any end in a decimal is called the limit of the decimal. We write a line on the digits which are repeated again and again. That means we draw a line on the limit. To convert a decimal fraction into fraction, let us observe the following examples. 0.4 is equal to 4 by 10 is equal to 2 by 5. 0.25 is equal to 25 by 100 is equal to 1 by 4. Conversion of fractions into decimal fractions. 1. 15 by 2 is equal to 7.5. 2. 19 by 4 is equal to 4.75. Conversion of decimals into mixed fraction form. 7.5 is equal to 75 by 10 is equal to 15 by 2 is equal to 7, 1 by 2. 2. 2.34 is equal to 2 plus 34 by 100 is equal to 2 plus 34 divided by 2 by 100 divided by 2 is equal to 2 plus 17 by 50 is equal to 2 into 17 by 50. Addition of decimals. While adding decimals, we should see that the given decimals are in the same form. The decimal places should come one below the other. The digits with same place value should be written one below the other. Add decimal numbers as in the case of whole numbers. Similarly, decimal points should also be placed at the correct place. Find the sum of 25.40 and 76.39. Solution. Write the given decimals vertically as shown below. 25.40 plus 76.39. Now add the values. We get 101.79.